Good day everyone, we are the BET AMT Wonders 2 and we will going to discuss all about the most generally used table in this time, the periodic table of elements. First, we will introduce ourselves. I am Jonathan P. Corrales. Nya.
I am Neil Magnaye. Yeah.
I am John-Mark L. Muaña. Yow.
I am Jerell D. Onte. Nurse.
These presentations give in-depth information regarding with the history, parts, and importance of periodic table of elements in the people. What is this table of elements all about?
The periodic table is one of the most important tools in the history of chemistry. This is a concise information-dense catalog of all the different sorts of atoms in the universe according to their structural properties in an informative way.
It was arranged from left to right and top to bottom in order increasing atomic number. The elements are arranged by electron structure so that many chemical properties vary regularly across the table. Each element is listed by its atomic number and chemical symbol.
Moreover, it was organized so scientists, researchers, and students can quickly discern the properties of individual elements such as their mass, electron number, electron configuration, and their unique chemical properties. The metal reside on the left side of the table while non-metals reside on the right.
Organizing the elements to help further our understanding was first provided by Dmitri Mendeleev. The periodic table of elements timeline from 1669 to 1945.
Date back in year 1669, German merchant and amateur alchemist Henrik Brandt attempted to create a philosopher's stone, an object that supposedly could turn metals into pure gold. He heated residues from boiled urine and a liquid dropped out and burst into flames. This was the first discovery of phosphorus.
In year 1809, at least 47 elements were discovered and scientists began to see patterns in the characteristics.
In 1863, English chemist John Newlands divided then the discovered 56 elements into 11 groups based on characteristics.
In 1869, a Russian chemist Dmitri Mendeleev started the development of the periodic table, arranging chemical elements by atomic mass, and he predicted the discovery of other elements and left spaces open in this periodic table for them.
Next trend happened in the history of the periodic table of elements is made in year 1886. A French physicist Antoine Becquerel first discovered radioactivity. Thomson student from New Zealand Ernest Rutherford named 3 types of radiation, specifically alpha, beta, and gamma rays. Marie and Pierre Curie started working on the radiation of uranium and thorium and subsequently discovered radium and polonium. Then, they discovered that beta particles were negatively charged.
And in the next year, 1897, an English physicist, J. Thomson, first discovered electrons, small negatively charged particles in an atom. John Townsend and Robert Millikan determined their exact charge and mass.
Then, in 1913, Bohr discovered the electrons moves around the nucleus in discrete energy called orbitals. Radiation is emitted during movement from one orbital to another.
In 1914, Rutherford first identified protons in the atomic nucleus. He also transmuted a nitrogen atom into an oxygen atom for the first time. English physicist Henry Moseley provided atomic numbers based on the number of electrons in the atom rather than the base on atomic mass.
Moreover, in year 1942, James Chadwick first discovered neutrons and isotopes were identified. This was the complete basis for the periodic table. In that same year, Englishman Cockcroft and the Irishman Walton first split an atom by bombarding lithium in a particle accelerator, changing it to two helium nuclei.
Lastly, 1945, when Glenn Seaborg identified lanthanides and actinides where atomic number is greater than 92, which are usually placed below the periodic table. The modern periodic table.
This is the actual modern table of elements looks like. And we have an example. Look at this element, hydrogen. Now, let's discuss the parts of the element in the periodic table. The 1IA and 1A is the group, and the number on the upper left corner of the element is what we call the atomic number. The 1 or 2 letters in the periodic table is the atomic symbol, and below it is the element's name. Moreover, the numbers in the bottom part of the element is what we call the atomic mass.
The table of elements is divided in three portions, specifically the metals, semi-metals, also known as the semiconductors, and non-metals or metalloids, and the noble gases that can be found in the last column, including hydrogen.
Next is element. An element is a pure chemical substance consisting of one type of atom. Examples would be carbon, oxygen, sodium, and iron.
An element is a substance that consists of atoms with the same atomic number. Element cannot be split into simpler substances using normal chemical methods.
Atom. An atom consists of a fixed number of protons, electrons, and neutrons, which makes each element unique. Protons and neutrons together make up the nucleus of an atom while the electrons orbit around it.
Next is the atomic number. The atomic number of an element is the number of protons on an atom has the number of protons determine what an element is. For an example, if an atom has 6 protons, it can only be carbon. The atomic number can also tell us how many electrons an atom has. From this, we can work out of how the electrons are arranged, and this will tell us how an element will react with others.
Atomic symbol. Atomic symbol or element symbol is an abbreviation chosen to represent an element. C for carbon, H for hydrogen, and O for oxygen, etc. These symbols are used internationally and are sometimes unexpected. For example, the symbol for tungsten is W because another name for that element will wolfram. Also, an atomic symbol for gold is Au because the word from gold in Latin is aru.
The standard atomic weight of an element is the average mass of the element in atomic mass units. Individual atoms always have an integer number of atomic mass units. However, the atomic mass on the periodic table is stated as a decimal number because it is an average of the various isotopes of an element. The average number of neutrons for an element can be found by subtracting the number of protons from the atomic mass.
The group. A group is a vertical column in the periodic table of elements. There are 18 groups in the standard periodic table. Elements in a group have similar configurations of their valence shell electrons, which gives them similar properties. The elements that occupy the same column on the periodic table, called the group, have identical valence electron configurations and consequently behave in a similar fashion chemically. Groups is a vertical column in the periodic table and is considered to be the most important way of classifying the elements. Lastly, the groups on the periodic table are labeled from 1 to 18. Group 1 is also known as the alkali metals. Group 2 is known the alkali earth metals. And group 17 is known as the halogens, and the group 18 is known as the noble gases. The elements in the group have similar properties.
The rows are also known as periods. The period number of an element signifies the highest energy level an electron in that element occupies. According to the Los Alamos National Laboratory, electrons in period increases as one moves down the periodic table. The Therefore, as the energy level of the atom increases, the number of energy sublevels per energy level increases. This is a horizontal row in the periodic table of the elements. The periods are labeled from top to bottom, starting with 1 and ending with 7. Group numbers. There are 3 systems of group numbers. One using Arabic numerals and the other 2 using Roman numerals. The Roman numeral names are the original traditional names of the groups. The Arabic numeral names are a newer naming scheme recommended by International Union of Pure and Applied Chemistry, also known as UPAC. The UPAC scheme was developed to replace both older Roman numeral systems as they confusingly use the same names to mean different things.
Electronegativity. Electronegativity is the tendency of atoms to attract electrons. The electronegativity of the element starts from about 0.7, goes up to 4.
Ionization energy. The first ionization energy is the energy needed to remove one electron from an atom in the gas phase. The ionization energy is different from each element. We can also define second, third, fourth, etc. Ionization energies. These are the energies needed to remove the second, third, or fourth electron respectively.
Atomic radius. It is generally stated as being the total distance from an atom's nucleus to the outermost orbital of the electron. In simpler terms, it can be defined as something similar to the radius of a circle, where the center of the circle is the nucleus and the outer edge of the circle is the outermost orbital of the electron.
Electron affinity. Electron affinity can be thought of as how much an element wants electrons.
Trends or periodicity. The periodic table is organized according to trends in element properties. The first trend is when you are moving left to right across the row of the periodic table, atomic radius decreases. Then, the ionization energy increases. The next is the electron affinity generally increases except the noble gases in the last portion. And lastly, the electronegativity increases. The second trend is when you are moving top to bottom down a column. First, the atomic radius increases and ionization energy decreases. The next is electron affinity usually decreases when you are moving top to bottom. And lastly, the electronegativity decreases. And now, this is the trends of periodicity of the periodic table. This is the summarization of the trends in the periodic table. There are several importance of the periodic table, specifically,
The first, accurately predict the properties of various elements and study relations between them. Second is keep track of newly discovered elements.
The next is it analyzes chemical behavior and two chemicals might react with each other. And fourth is people also gain information from the periodic table by looking at how it's put together. By examining an element's position on the periodic table, one can infer the electron configuration.
the next is the people familiarization with how the table is put together can quickly determine a significant amount of information about an element. And lastly, it describes the atomic structure of all elements that are known to mankind. To summarize, the periodic table is important because it is organized to provide a lot of information about elements and how they relate to one another in one easy-to-use reference.
The table can be used to predict properties of elements, even those that have not been discovered. Second is columns, groups, or rows, periods, indicates elements that share similar characteristics.
Fourth, the table provides important information used to balance chemical equations.
First one is it defines periods and groups and describes how various electron configurations affect the properties of the atom. The next is it explains the arrangement of elements in the period table.
7. It describes the atomic properties of every known chemical element in a concise format. Include the atomic number, atomic mass, and the relationship between the elements. 8. The group on periodic table are labeled from 1 to 18. Group 1 is known as the alkaline metal, Group 2 is known as the alkaline earth metal, Group 17 is known as the halogens, and the Group 18 is known as noble gases. The element in the group have similar properties.
9. The atomic radius and density both increase down a group. The ionization energy, electronegativity, and melting and boiling points all decreases down a group.
Conclusion. We concluded that this periodic table of elements was in depth studied by many scientists before. It was very important in this generation. Shows all the information needed by the students, teachers, researchers, and scientists. Therefore, it is the best to analyze, understand, and memorize this table of elements because it is very helpful to people. Thanks for watching!